Hello, everyone. I'm Ram from ThoughtWorks. We are a vendor partner for the Singapore government and many ministries and agencies for very many years. We've been in the industry for about 26 odd years. We are the company who created the first continuous integration software called Cruise Control. One of our colleagues authored the book called Continuous Delivery, and along with Dave Farley, this was Jez Humble and Dave Farley. And Jez went on to create the DORA metrics, which is very widely used in the industry. So let's just go on with the presentation. Essentially, I will be covering over here the journey to continuous delivery. Now, the previous speakers have spoken about why continuous integration is important, what does it mean to be agile, and why it is imperative that everyone embrace these principles. I will talk about what does it mean for us from the vendor point of view when we come into an agency or in any private sector client. Indeed, what does it take for us to make sure that we are delivering on time and we get paid, right? So, yeah, we will be covering this agenda, which essentially I hope to share with you what does the journey actually look like beyond subscribing for the ship or hat services if you're in the government sector, or beyond deploying the continuous integration tools if you're in the private sector on your own. But what does the journey actually look like? What are your teams going to have to do? And what are the benefits that you will start to see so that you know, yes, you are on the right path, right? We start with looking at what we call the key measures of success. The table of figures that we see on the left in the slide, these are from the State of DevOps report in 2016. Puppet Labs and DORA, they got together and they put out these metrics. This is what the high performers aim for. And they aim for this not just for the brag value, but for the benefits that we see on the right-hand side. Most important for everyone being the ability to respond to change. The ability to respond to change is not just, you will hit this date and make this happen because my Excel spreadsheet says so, but it is more that you should be in a position to do so to meet the changes in the market, or let's say there's a security or performance issue and you have to respond to it, or you tried out a feature, it's looking bad, you need to roll back and push out something better. So the ability to respond to change is more important for a lot of real world reasons than some arbitrary date, right? Part of all of this conversation, and we as vendor partners face a lot of problem with this, when CI/CD turns out to be anything and everything to very many people, So I just thought I'll put a mild bit of demystification over here. The difference between continuous integration, deployment, and delivery. Continuous integration is when developers integrate their work with each other on a frequent basis, as we will see why. Deployment is often, hey, I've got an artifact ready, I would like to deploy it. But very many people often say that because I need to have continuous deployment, I don't want to be tied on by a lot of these gatekeeping checks. But that causes you a lot of problem because you may deploy frequently, but you may not ensure quality necessarily. So continuous delivery is when your code is in a deployable and functionally correct state, right? We'll be sharing these slides later. I'll just keep talking. Click. Yeah. This is what good looks like when you have continuous delivery in place. The product owner, the environment owner, those sorts of folks should be able to look at one commit, make sure that it has gone through the right review, and be able to deploy on demand. That on demand can either be just some automation that they say wherein it is truly continuous without human intervention, or at least a human click. But they should be able to make sure that certain due diligence has happened and that certain gatekeeping checks have gone through. Now, the gatekeeping checks need not be all manual. To the extent that they can be codified and put in part of the pipeline, let them be automated. But when someone says, do we have continuous delivery in place? This is what continuous delivery is going to have to look like to them. So they should not have to wait for 3 months or 6 months or whatnot. A typical delivery iteration should take about just a week or two, right? And with a lot of periodic deployments during the day. So you now move away from something like a once in 3 month or once in 4 month release to being able to go live whenever you need to. And this is very important whenever you have to push fixes out, because a computer software or workflow does not care what your release schedule looks like. What the customers care is the software they expect to see should be working correctly. So therefore, you see, continuous integration is just one of the many blocks over here. To be able to deliver flawlessly and continuously and regularly, you're going to have to make sure that there will be a lot of these other practices in place, which help you make sure that as a vendor partner, you have the right practices in place so that you can fulfill the contract and the requirements. And as a customer, you know that the software is being developed with the right quality checks and others being taken care of. So here are some practices, and here are some others. Right? You would have a lot of these practices that you would have to put in place. This then leads us to a very interesting realization, right? What does it mean to get started? Here. Continuous integration then is where you get started. You get started with making sure that your code is in a version control. Your developers are not developing in isolation and sharing files with each other via file share or just email or something. But you want to make sure that your developers are able to check out, check in code, and continuously integrate with each other. We will just see what does it mean to integrate. But essentially what ends up happening is they merge their code with each other on the same branch, and you have a continuous integration service. ShipHats provides that. You have a continuous integration service that monitors that code for you, assigns various build and test jobs to various agents who perform those checks for you. These checks need not just be whether the code compiles or whether it is packaged correctly. They can also include a whole lot of checks and static analysis and dynamic code verification that is often required. Again, Chaho had just spoken about this, the importance of DevSecOps, and one of his points that he had said was, in the ShipHats world, a lot of these tooling are made available. I can attest to that as a vendor partner. We use Ship, and a lot of these things which take weeks to set up and argue over and debate about settings, now we just get into a project, is just there available for us. So we as a team are able to focus on getting software delivery started. This is a very wonderful thing. The other interesting thing, so this was for us. The other interesting thing that we see with our clients, government sector or private, is once a CI system is in place, they are able to look at the commits on a regular basis. There is no ambiguity of did someone commit the code or not. It's either there or it isn't. The CI dashboards tell you whether the code has passed, and if it has failed any checks, what do you do about it. The good bit is we don't get into any you versus me debate on all of this. The code is there, the configurations are there, and we just resolve ambiguity by just looking at it right away. We are therefore in a position to spot failures now rather than 3 months down the line, where we would have built up a volume of work and people have to debate on, shall we just let it go through, right? We don't have to get into that ambiguity anymore. We can resolve ambiguity within the day often. It's wonderful for us. So what does it mean to get started? It doesn't just mean that you set up, you subscribe to Ship and you get access to source control and to Bamboo and get your builds going. What it actually means is making sure a lot of these gatekeeping checks are in place. This usually comes down to the definition of done. When people say, oh, I'm done. When are you done? Are you done when you are dev complete on your laptop? When you say it works on my machine? Or are you done when an independent software agent, like the continuous integration service, when that takes the code, compiles it, puts it through all sorts of verification, and make sure that it's deployable and it has been tested? Is that the definition of done? Usually you will find out that is this list is a better definition of done. It's not just enough that you got it running on your laptop. So is the source code in a version control? Is a system able to generate deployable artifacts? Is this deployable? Can this get automatically deployed and configured somewhere, preferably without human intervention? And post that, are there verification tests that have been run, right? Once you're able to do something like this, you as a developer can say, when I checked in my code, it went through all of these checks, and therefore it continuously integrated with the earlier developer who had just checked in. And then someone else who follows me, because now they have to check on top of their changes will be on top of mine. They will also have to go through these gatekeeping checks and thereby integrate with me, right? So continuous integration is not just subscribing to a service, but it's making sure that you activate and provision and go through these checks. So far we have, we have gone through and looked at what is continuous integration, and now let's look at what is continuous delivery. So remember this, I had said that this is what a continuous delivery looks like. so that you can demonstrate, that you're adhering to the good measures of success, right? So, and remember, please, that we had discussed there are all these practices that will lead to it, because it's not enough that you have just committed code. It's not enough that, ship has ran your code and ran the checks for you. What is also important that you as a team are geared up with all the right processes and all the right practices to make sure that you are actually writing good code. You have to be in a position of saying that I shouldn't have to, for example, we've got this thing on epics and stories. You should not be in a position of saying, oh, I'm picking up this chunk of work, which is going to take me 3 months, and then I will meet you then. You should be in a position of saying, what is the thinnest vertical slice of functionality that I can code and push in, which can go through all the right checks and maybe even go live, right? So it is not enough that you just declare continuous integration in place, declare you have automated deployment, thumb the table and claim continuous delivery. You won't be able to achieve it. Those are, unfortunately, the tools can go only so far. They cannot take you much farther. The rest of the journey is yours, right? So what does it mean? Yeah, this is what then now becomes a roadmap to continuous delivery. After you've had your continuous integration in place and you start to put in a lot of those processes, you'll have to make sure that you also facilitate for the testing and for verification a lot of these things. You want to make sure that all your environments are uniform. You shouldn't have a situation where something ran in a test environment and is failing in prod. One of the very nice things that was brought up earlier was about GCC, and at least in the projects that we work on, we make sure of this. We use infrastructure as code. I'll show you some very nice examples. We use infrastructure as code to make sure that all our environments are uniform. The next thing that you have to look for is to make sure that your deployments and your configuration are consistent. That means it should not be that you deploy with automation in prod and then you deploy with manual approaches everywhere, hot patching jars or updating files by hand and all. No. We need to move away from that. We need to move away from that, not just because it causes us problems, but also because now the tooling exists that we don't have to succumb to all that. It is now easy to decommission and recommission a virtual machine. And if you have made mistakes, there is no need to go and cause ourselves trouble. And of course, then the other points come up that go ahead and make sure that your artifacts are verified, and go ahead and make sure that you have all of these checks and conditions in place, right? So this is what a typical roadmap for continuous delivery would look like. Let's just see a few of these interesting things. This is a very common word, okay? An environment. So you have named environments like QA, SIT, UAT, and all of those things. What actually is an environment, right? By the way, these are slides created by my colleague Jinchi, and she put in a lot of thought to come up with a lot of this articulation because we have to keep doing this with many clients. So actually, at the end of the day, this is all that is an environment. In today's world, where you have a lot of infrastructure automation as code, and automated deployments and verification and all of it. So actually, an environment is just all of these things where a developer and an ops person, they sit together. It becomes DevOps, and they understand what comprises an environment, which of that much can you automate with code. So you automate an environment creation with code, you automate deployment and configuration again with code, you create database schemas completely with version control, you back it up, and you move all logs and metrics and everything off the computers. So the earlier needs where we would say that, oh, I must retain logs on the machine for 60 days, we can now do away with it. A machine thus no longer becomes precious. It can be decommissioned and recommissioned at will because you can recreate an environment, and environment now is all of these, including virtualized services in your lower environments. So DevOps, when one says DevOps, it is actually a combination of making an environment via automation when you work with ops teams, and it is also making sure that you have automated builds and environments where all of this flows through. So when you're told, oh, you must have CI/CD and you must have infrastructure automation, what does that actually mean? Here is how it will actually flow through. Here is what DevOps in practice looks like. So for example, here you will see that there are a bunch of services. There is database as code, there is infrastructure as code, there's configuration also, version control. You take all of these, they go through the pipelines, you put them into an artifact repository, and then on demand, or in this case via automation, you take those when they are ready, deploy to a functional test environment, which you create via infrastructure as code. See the blue box at the bottom. And in that, you deploy your application, run your automated tests, and you certify that combination of artifacts. So once you have this certified combination of artifacts, you can now take this and keep pushing it into all future environments, all of which you create via code. So when you are able to leverage, whether it is GCC or even on-premise VMware automation, this is how it actually translates into, right? And in order to do this, you have to work with ops teams. It is not enough that you just go and do some $20 course somewhere and say, oh, I have learned all this on my own, I'm a DevOps guru. You have to work with ops teams to make sure what does it take to go through all this and bake in a lot of the gatekeeping checks. One of the nice bits about the ship side of things is a lot of these gatekeeping checks are available out of the box, right? What does a test look like? Let's look at this side. Let me just show you the previous side. See, there's a very important thing here. The boxes on the left where we showed all the services, what those actually do is, that's a very tiny box there, but I can tell you there's a lot of stuff that you can do using the ship framework to actually work out over there. You compile the code, you package it. In parallel, you can also run a lot of static and dynamic analyzers. If you're using containers, it'll do a lot of container checks for you. And you get a lot of Fortify-based scans with which you can do a lot of, it preempts a lot of security findings that would otherwise come or which you waste time on. So that takes care of what ship can do. But what about all the business level code quality? That's where the concept of the test pyramid comes in. So, if you look at Martin Fowler's website, he has taken Mike Korn's test pyramid and he has gone and written a nice article about it. What does that translate to us developers on the ground, right? A test pyramid flash in a slide deck is one thing. But when a dev asks me, hey, how do I make this test pyramid happen? You actually make it happen like this. You have to understand what kind of tests do you need at what layer. And depending upon the kind of test, they will fit into that layer. So I just put together a very conventional example, e-commerce, which we all understand, where a typical workflow would be, I added an item to a shopping cart and I want to check out. And now what if the checkout process fails? This is the most critical value, the most critical path in an e-commerce workflow as we can imagine. So this is how a typical test flow would look. A high-level test that just clicks about at a UI, right, is just going to tell you, hey, the checkout process failed. That's great for a grand total of 3 seconds. You want to know where it failed, but more important, you want to know why it failed. So as you test drive the code, as you write code to specifications and then write, allow me to revise, as you write expectations to the acceptance criteria, which are called tests, and then as you write business logic to clear the expectations, which is your actual logic, then you will have arrived with test-driven development. And the more you write those, you will get into situations where you preempt issues even before they happen in a test environment, because these acceptance criteria would have got validated, right? So the reason it's called a test pyramid is the more developers realize that unit tests are really wonderful, you will end up with a lot of them. So you come up at the bottom of the test pyramid there, right? And once you have this test pyramid, you would fit your tests in this, right? This is what a pipeline looks like. It is not just a subscription in ship or whatever else you use. It is not just someone giving an Excel report, but your tests are actually laid out in this sequence. So as we lay out tests, the faster and the earlier feedback we get, the better for us. And because functional tests and regression tests take a lot of time, what ends up happening is we lay those out later, but you get an increasing amount of confidence because the why it failed or why it might fail, you catch much earlier. And the others are just intercomponent integrations. So once you have tests laid out like this is what a real world pipeline graph looks like, okay? It is not, it is more than just someone saying, I've got a CI/CD pipeline. What we people on the ground, we end up doing is we lay out our pipelines like this. We make sure that, for example, let's say team A has to give us a library. Team B has to consume it. What does it mean for us to consume? So we would take stubs and mocks and you lay it out. We would take up a library, deploy it locally and run a test, then promote it to the next environment and run higher level tests. So something like this, which is just abstract blocks, ends up becoming something like this, where we can trace from left to right. We can also trace from right to left, wherein we want to say what components went in over here. So we want to be able to trace back. So this is what a real-world pipeline graph looks like. So folks, my time is up. I just hope you found this session to be useful, which tells you what does continuous delivery on the ground look like, and why is it that tools just take you for part of the journey and you have to do a whole bit more yourself. But if you do it, you preempt a whole lot of pain going forward. Thank you.